In this problem, a given pumping well fully penetrates an unconfined aquifer, which sits above an impermeable layer beneath it. The impermeable layer is 150 feet below the surface of the ground. The well is 18 inches in diameter, and the average permeability of the aquifer soil is 175 feet per day. An observation well 800 feet away assists in determining that the flow rate out of the pumping well is 2,250 gallons per minute by measuring the depth of water there at 25 feet below the ground surface. Assume that the ground surface at each well is the same. What is the height of the water above the bottom of the aquifer at the pumping well in feet? So this is a really long problem to read out, and it contains pretty much all of the information that we need. We just need to know how to put it together. So the first thing to note is that this is an unconfined aquifer. Pages 425 and 426 of the reference manual have information about unconfined aquifers with respect to wells and groundwater flow. So we can find it just by searching well in the reference manual. Specifically, the equation we will use to solve this problem is given as Dupuit's formula. I have already also drawn out the graphic included in the reference manual on these pages so that I can more easily show you what each term in the equation actually represents. So let's start filling in our knowns and see what we have to solve for. So we have Dupuit's formula here, and we can see what information we've been given throughout the problem. So Q has been given as 2250 gallons per minute. K is going to be our hydraulic conductivity, and that's been given at 175 feet per day. H1 is the height of the water above the bottom at the pump well perimeter. H2 is the height of the water above the bottom at the observation well. R1 is the radius of the pumping well. And R2 is the radius from the pumping well to the observation well. So let's start filling in our knowns. Height 1 is what we're going to be looking for, since that is the height of the water above the aquifer, above the bottom of the aquifer at the pumping well. So we don't have this value yet. Height 2 is going to be given as the difference between the depth below the surface of the ground, so this entire length, minus the depth of the water below the ground surface at the observation well, equals 150 feet minus 25 feet equals 125 feet. The pump well radius we already know because we've been given the diameter in inches up here. So that's going to be 0.75 feet. And R2 is going to be 800 feet away from, is the observation well distance away from the pumping well. So that's just 800 feet. So we can see that we have all of our terms. We have K, we have H2, we have R2 and R1. The only thing we're missing is H1. And we have Q, like we mentioned. So we just need to change the units in Q so that they match those of K, and we can just proceed to solve the problem. So Q is gallons per minute. We want to convert this to feet per day, so, or cubic feet per day. Multiplying all that out, we get 433,155 cubic feet per day. And now we can set up the rest of the equation. So rewriting Dupuit's formula over here with our knowns in it, we can say 433,155 feet cubed per day equals pi times k is 175 feet per day times h2 is 125 feet, so 125 feet squared minus h1 squared over ln. R2 we mentioned was 800 feet and R1 is 0.75, so 800 feet over 0.75 feet. And now all we have to do is simplify this down. If we start by multiplying the quantity of ln here over to the other side of the equation and then simply dividing out our pi and our k, we get 5496 feet squared equals 125 feet squared minus h1 squared. Rearranging this, we can say h1 squared equals 125 feet squared minus 5496 feet squared. And squaring this, doing the subtraction, simplifying down for h1 gives us 100.64 feet, which we can see over here is our second answer on the list. And that's all it takes to solve this problem. So the most important thing in this particular question is understanding that this is an unconfined aquifer, and then recognizing what your H1, H2, R1, and R2 values are. And also understanding how to solve for what your H1 and H2 are supposed to be. In this case, you only had to solve for H2 by subtracting the total depth, or rather by subtracting the depth of the observation well from the ground surface from the total depth of the entire aquifer. And that's it.